guys, welcome back to another video. This is Educational Codeforces Round 147 and the problem is sort the subarray. So subarray, for people who don't know, subarray is like a small subset from an array which is having continuous elements, okay, continuous set of numbers. You are just picking that. So let's quickly see what the problem states. The problem states that you have two arrays, that is A and A dash. Then there are two indexes, that is L index and R index. So monocarp is a fellow who picks an index called L equal to 2. That is this index, that is L equal to 2 and R equal to 5. 1, 2, 3, 4, 5. This is not 0 index, this is 1 index, okay. Now what this guy does is, on the array A, he sorts these integers from L to R. That is 2 to 5 he sorts. 6, 6, 5 remains same. 6, 6, 5 remains same. But 7, 3, 4, 4, he tries to sort it. If 7, 3, 4, 4 he tries to sort it, means how it happens? It's 3, 4, 4, 7. So that's how you got 3, 4, 4, 7. So 2 equal to 5, from L equal to 2 to R equal to 5. Now our job, what is our job? These are the problem. So our job is, you are given two arrays, they will give you A and A dash. We need to find two integers L and R that monocarp would have chosen. Catch is, if there are multiple pairs of values, find the one which corresponds to the longest subarray. That means if there are multiple sorted values that monocarp could have chosen and sorted it, we have to find the longest of it. So like we'll just try to think and solve this problem. How are we going to do it? This is the same thing as the example that I showed you, right? But let's try to derive a solution a bit from it. So there is only one operation that happened from A to A dash. Do you agree with that? There is only, monocarp took only L and R and he tried to sort it. So what happened is, there is only one operation and all the other numbers are same on both the arrays, right? So let's try to apply that logic here and see if it works or not. So if 6, 6 is there, monocarp did not do anything. If 5, 5 is there, monocarp did not touch these because positions are not changed. We are just assuming. 6, 6 is there, positions are not changed. But here 7, 3 is there, no? So we assume that, okay, monocarp could have changed L equal to 2. Now you come backside, 4, 7, again it's changed. So I think monocarp could have do L index 2, 3, 4, 5, R equal to 5. Now let's see the solution 2, 5. Okay, this is already an example. What did we assume? We assume that there is only one operation that's done, and one operation is like sorting the subarray, and if any other numbers are not disturbed, it is directly transferred from A to A dash. So we just got this. Now let's see the second one. That is 1, 2, 1 is A and 1, 1, 2 is A dash. So according to our logic, what do we do? Okay, monocarp might not have sorted this and this. He did not use it because both are same. He did not apply the operation, but here it's a change is there. So what we do, you put L equal to 2 and 1, 2, again a change is there, you put R equal to 3. Now let's try to see the solution. Okay, the solution went wrong, 1, 3. Why? Because in the question they have told that if there are multiple pairs of values of LR, find the one which corresponds to the longest subarray. Here monocarp could have chosen the entire array, right? If he chosen the entire array, the value will be 1, 1, 2. If we have chosen only 2, 1 also, the value will be, sort this, it will be 1, 1, 2. So the longest LR is A and A dash. So we got that, okay. Now we got that if it is same also can come, but he could have chosen different LR also. So let's try to understand it a bit further. Let's see one more problem. This 2 to 1, 2, 2, 2, 1, 2. According to our logic, what? If A and A dash is same, I am not going to consider this. This is L equal to 2 and this is L equal to 3. Okay, here I am sorting it, it is 2, 1, 2. But why didn't he take this? This is just 2, 3, right? For that, I have a good example for you to understand. So this is where you need to find out. This is where we need to figure out why here this left side value is taken and why here the left side value is not taken. Just pause the video. If you want to think about it, you can just think about it and then you can come back. So I hope you made your efforts. So let's see this problem. So according to our logic, it is, you did 100, 100, A and A dash is same, monocarp did not apply any logic, 2 and 2 is same, monocarp did not apply any logic, 7 and 3, something is happening here. So I just do that, okay, I'll just assign it as first value is 3. I'm just starting like that, okay. Now come from back, 9 and 9, nothing is there, 8 and 8, no, 3 7. Okay, something is happening here. So second I assumed as 5. Monocar could have sorted 7 4 3 to 3 4 7, but the answer is wrong here. He have taken this 2 also. Why did he take 2 is this number 2 and number 3 is less than or equal to, right? It is already sorted. So even if he takes this 2, there is no harm in it. So after I check this, I am coming back and seeing the what is the best value I can come with first one. So first one is 2 here, because I am just coming back and seeing whether it's sorted or not. 2. Can I move one step further here? Because this is also same, I can also move one step further, right? No, it's not possible because this is not sorted. 100 is more than 2, right? Here 2 is less than 3. The right side value should be more in a sorted order and left side should be small. Here the left side is more and right side is small. So we are stopping it here. Monocar should have started from 2. Okay. Now we go here. Now let's say 7 and 8. The left value should be smaller, right value should be bigger. So what I'll do, I'll have a temporary placeholder that is called second one is equal to 6. Can I go one step further? Yes, because 8 is less than or equal to 9. It is a sorted order, so second value becomes 7. Now, what is the highest LR? If first one is defined, it is 2. And if the second one is defined, it is 7. So you are getting from 2 to 9. What did we do? We understood that there is a difference in 7 3 and there is a difference in 3 7. We assumed that first and second, these are the values. Then we are trying to expand it on the left and expand it on the right. These are already sorted. Even if we expand the L value, there is no harm in it, right? 2 less than or equal to 3, there is no harm. He could have chosen the entire 2 7 4 3 8 9. He could have sorted it to 2 3 4 8 7 9. Now let's see how this happens. 1 2 1 1 1 2. What is the first value here? That is a 2 because there is a mismatch. And what did we do? Second value is 3. Can we go left side? Yes. You have to check on A dash only. Okay, very important thing, because A dash is the produced value. 1 is less than or equal to 1. So Fi dash, these are all placeholders. 1. Now here Fi dash is defined, so 1. Do I have Si dash? No. So what is this? This is 1 2 3. So I got everything. Now let's see this one. 2 2 1 2 1 2. What did we do? According to our logic, Fi value is what? 2. That is L value, and R value is what? I am just putting second. That is 3. Can we go left? Can we go left in A dash? It is not possible because the left side value is smaller. Less than or equal to 2 is less than or equal? No, right? So Fi dash and SC1 is not, SC dash is not defined. So you are simply putting Fe2 and SC3. I'll show you the code. Then I hope you will be able to understand it. So this is the code, this is a submitted solution, so you can just have a reference. I'll attach it to the description also. So what I'm doing is, initially I'm getting A of I value and A dash values. A dash I'm telling as A1. Now what does this code do? I'll just come from the left, and whenever I see a mismatch, I understand that that could be an L value. So I am keeping first as index I. That's done, we got it. Now come from the last. If it is same A and A dash, there is no change, monocarb did. R, there is one mismatch. Okay, I understand that there can be a chance that monocarb could have chosen R and then he might have tried to sort it. So second I also I break. Now the thing is, monocarb could have extended those values, right? The numbers might already be sorted, but he could have extended it. Now what did we do? If the right value is more than the left value, we just keep use a new variable called as first one and keep iterating it to the left. If you want, you can use the first variable itself, but since I used it here, I did not use it further. So first one, you just keep iterating to the left, and similarly here also second you iterate it to the right. And here what I did is, if the first one is not equal to -1, that is, after I found the mismatch, I could not find any other values that satisfy the condition. I just kept first one plus 1. Why did I use plus 1 here? Because it is 1 based indexing. I was working on 0 based indexing, so I kept first one plus 1, and this is first one plus 1. Then you just have to put space, and then you do second one minus 1. That is when will second one not equal to -1? So suppose in this case, right, if it is end of the string, or if it is like it doesn't have any more value to go ahead after second. Suppose if it is like 1 here or 1 here, this can't go ahead, right? So second one will be -1 only. Only if it is a number greater than this, second one will be created and defined. So in that case only we are doing second one plus 1 and second plus 1. So that's all, guys. Just relax, and if you're not able to do, try to solve it in a piece of paper and go through this code. then you can see some more test cases and you'll be able to understand. It's only the tricky part is you are finding the mismatch. If the numbers are same, it will be a and a dash will be same. Only catch is we just have to find the number where there is a change, where the sorting happens, and then you need to extend it based on the problem, that is how much long the a dash has been sorted. So that's all. If you like the video, please comment it, and if you don't like the video also, no problem. Just share your suggestions, and I hope that this video will be useful for you. Thank you.